Another Day, Another Story. A Brief History of Time, written by the renowned physicist Stephen Hawking, was first published in 1988. The book aims to explain complex concepts in cosmology to a general audience. It covers various topics, including the Big Bang, black holes, the nature of time, and the search for a unified theory that combines general relativity and quantum mechanics. The universe and its origins, the Big Bang theory as the origin of the universe. Welcome to Tabo Eminent Channel. The expansion of the universe and how it can be observed through the redshift of distant galaxies. The nature of time, the concept of time as a dimension. The arrow of time and its relationship with the second law of thermodynamics, which states that entropy, disorder, tends to increase over time. Black holes, the formation and properties of black holes. The concept of the event horizon, beyond which nothing can escape the gravitational pull of a black hole. Hawking radiation, the theoretical prediction that black holes can emit radiation due to quantum effects near the event horizon. The uncertainty principle, the principle introduced by Werner Heisenberg, stating that certain pairs of physical properties, like position and momentum, cannot both be known to arbitrary precision simultaneously. Elementary particles and forces, the standard model of particle physics, which includes fundamental particles like quarks and leptons, and the forces that govern their interactions. The quest for a unified theory, such as string theory, that would reconcile general relativity and quantum mechanics. The shape and fate of the universe, different possible shapes of the universe, open, closed, and flat, and their implications for the ultimate fate of the cosmos. The role of dark matter and dark energy in the evolution of the universe. The anthropic principle, the idea that the laws of physics and the constants of nature are fine-tuned in a way that allows for the existence of life. Impact and reception. A Brief History of Time became a bestseller and has sold millions of copies worldwide. It has been praised for making complex scientific ideas accessible to non-specialists, although some readers still find parts of it challenging. The book has also inspired numerous discussions and further readings in the fields of cosmology and theoretical physics. Legacy. Stephen Hawking's work has had a profound impact on both the scientific community and the public's understanding of the universe. A Brief History of Time remains one of the most influential popular science books ever written, and it has cemented Hawking's status as a key figure in modern physics. The universe and its origins. The Big Bang Theory. The Big Bang Theory proposes that the universe began as an incredibly hot and dense point approximately 13.8 billion years ago. This initial singularity expanded, and from this expansion, space, time, and all matter were created. Hawking explains how cosmic microwave background radiation and the distribution of galaxies provide evidence supporting this theory. Expanding universe. Edwin Hubble's observations in the 1920s revealed that galaxies are moving away from us, indicating that the universe is expanding. This discovery supports the Big Bang theory. Hawking discusses how this expansion can be observed and measured through the redshift of light from distant galaxies. The nature of time. Time as a dimension. Time is treated as the fourth dimension in the theory of relativity, along with the three spatial dimensions. This concept allows for a more comprehensive understanding of how time and space are interconnected. Arrow of time. The arrow of time is the concept that time has a specific direction, always moving from past to future. This idea is closely related to the second law of thermodynamics, which states that entropy, or disorder, tends to increase over time. This explains why we remember the past but not the future. Black holes. Formation and properties. Black holes are formed when massive stars collapse under their own gravity at the end of their life cycles. They have such strong gravitational fields that not even light can escape from them. Hawking describes their key properties, such as the event horizon, the boundary beyond which nothing can escape. Hawking radiation. One of Hawking's most famous contributions is the theoretical prediction that black holes can emit radiation due to quantum effects near the event horizon. This radiation, now known as Hawking radiation, suggests that black holes can slowly lose mass and eventually evaporate. The uncertainty principle. Heisenberg's principle, the uncertainty principle, introduced by Werner Heisenberg, states that the position and momentum of a particle cannot both be measured exactly at the same time. This principle is a fundamental aspect of quantum mechanics, highlighting the inherent limitations in our ability to predict the behavior of particles at very small scales. Elementary particles and forces. Standard model of particle physics. The Standard Model is a theory that describes the fundamental particles and the forces that govern their interactions. It includes particles such as quarks, leptons, and bosons, and it explains how these particles interact through the electromagnetic, weak, and strong nuclear forces. Quest for a unified theory. Hawking explores the idea of a unified theory that would combine general relativity, which describes gravity, with quantum mechanics, which describes the other three fundamental forces. String theory is one such candidate, proposing that fundamental particles are actually tiny vibrating strings. The shape and fate of the universe. Possible shapes. The universe could be open, expanding forever, closed, eventually collapsing back on itself, or flat, expanding at a rate that slows down but never quite stops. The shape and fate of the universe depend on its total density and the amount of dark matter and dark energy present. Dark matter and dark energy. Dark matter is an unseen form of matter that does not emit or absorb light, but has gravitational effects on visible matter. Dark energy is a mysterious force driving the accelerated expansion of the universe. Together, they make up most of the universe's mass-energy content and significantly influence its evolution. The anthropic principle. Fine-tuning. The anthropic principle suggests that the laws of physics and the constants of nature are fine-tuned in a way that allows for the existence of life. This principle can be interpreted in different ways, from the idea that our universe is one of many, the multiverse, to the notion that certain conditions are necessary for observers like us to exist. Personal and scientific context. Stephen Hawking's life and work. Stephen Hawking was diagnosed with amyotrophic lateral sclerosis, ALS, at the age of 21. Despite the progression of the disease, which left him almost completely paralyzed, Hawking continued his work in theoretical physics and cosmology. His perseverance and contributions to science have made him a symbol of intellectual triumph over physical adversity. Hawking's work on black holes and his collaboration with Roger Penrose on the singularity theorems have been groundbreaking. His ability to communicate complex scientific ideas in an accessible way has inspired millions and brought cosmology into the public eye. Impact of A Brief History of Time. Upon its release, A Brief History of Time became an unexpected bestseller, remaining on the Sunday Times bestseller list for a record 237 weeks. In summary, A Brief History of Time is not just a book about the universe, it is a story of human curiosity, resilience, and the quest for understanding our place in the cosmos. It remains a landmark in scientific literature and a testament to Stephen Hawking's extraordinary life and mind. Thanks for watching. Request you to subscribe the channel.